Alright, welcome back to the second part of Lecture 8, Part 2 for Engineering 101 in 2016, and this is the last of our series of lectures on the little man computer, and the last topic we have to cover with the little man computer is this concept of loops. And you'll come across loops, if you haven't already, in your programming courses in Comp 102, Comp 112, Comp 103. Loops are a really common programming structure in every single programming language known to man. So the last thing we need to do is have a look at how the little man computer can get himself stuck in an infinite loop, and then maybe even do some conditional selection based on that. So here's the full list of operations we had for our little man computer that I put up a couple of lectures ago. And you can see the add, subtract, store, load that we've had so far, input, output, halt, and dat, which was the last one. And so the three we haven't talked about yet are BRA, BRZ, and BRP. The BR stands for branch, and the A, Z, or P. A says branch and go to a certain point. BRZ says branch on 0, and BRP says branch on positive. So I'll come in and explain BRZ and BRP in a moment. So let's focus on BRA at the moment. BRA, and that is encoded to 6 followed by two other numbers. So let's say, for example, we're going to use the opcode 604. When we hit branch, as our little man is stepping through our program, once he hits branch, that says go back and reset your program counter to line number 4, which is the equivalent in our code of jumping 4 implemented. A really good reason for why you might want to do this is to get a program to repeat an action forever. If you're familiar with programming, this is the concept of a while loop, which runs forever while something is true. So, for example, the software I'm using to record this lecture, it's not sitting in a loop counting down until I'm done. It's sitting there in a while loop waiting for me to say, yes, the recording is complete, and then it will exit. So that's the idea of a loop that will run forever until something happens. Here's how you do that in the little man computer. So if you have a look on at the assembly code on the left hand side, you can see we've got a load command. So we're loading a value from our variable. In this case, just to remind you, that variable has the value 13 when we start. We output that, and then BRA0, that branches our program back to line number 0. So let's just go through the little man process for this whole step here. So LDAA, our little man computer goes and looks for where variable A is stored in the memory address. He gets the value of that, which we can see from line 4 is set to be 13, and then he outputs that. So he copies that from his calculator to the output. Then he hits this BRA0 command. That BRA0 is a command that tells him to go over to his program counter and overwrite it. Regardless of what value it is, he sets it to be this new value here. And in this case, he's setting it to be 0. So then he goes back, loads that value again, outputs it, hits this, goes back, loads that, outputs it, goes back, and so he gets stuck in this infinite cycle. So he will never move on to line 3, which is the halt statement, which is a really interesting process. You will have all seen this hopefully by now in the lab, where you write these infinite loops and the little man computer goes on forever and ever and ever and ever and ever and ever and ever. Now, branch won't always make you hop backwards. If we had a command that was, let's say, branch 12, we could make him skip all the commands that were down here, like let's say we had a halt, and then we had a B dat 19, all of those. If we had bra 12, once we hit that, instead of looping back to the start, we would skip all the way down here to wherever line number 12 was, and we could have a whole bunch of different code written down there. So you can make your program loop forever, or you can make it skip large chunks of itself. Now, usually you don't want a program to skip large chunks of itself, right? Then what's the point of running the program? In general, you only want your program to skip in certain situations, if something is true or if it's not. And that process is called a conditional statement. That's what those other two BRZ, BRP commands were for. So BRZ and BRP, these are conditionals. They allow you to ask if something is true, and if they are, you do something. If you don't, you do something else. So I don't expect you to know BRZ or BRP or how to implement them for tests, you should know that the little man can do conditional statements, because you'll be using them in Comp 102 very, very regularly in all your programming going forward from there. BRP and BRZ, all they say is do something, do that skip, just like BRA did, either forwards or backwards, but they depend on what is in the result, what is written on the little man's calculator at any one time. So a BRP command might look like this, BRP 12, and that says if I get to this line here, and the value on the surface of the little man's calculator, if the result field is a positive number, so anything above 0, then go to that line there. Skip all the way to that line in the code or go back to there. BRZ, that does the same thing, so let's say BRZ 13. When you get to that line, it says if the value in your result field is 0, then skip to that line there or go back to that line there. So the combination of these two allow you to test if something is true or not, and if a number is positive or if it's 0. So here's an example of it being used. Again, I'll let you go through this in your own time if you so desire. But what you can see here is that we have a program that does two different things based on what input you give it. If you give it 0 input, then you'll skip to line 3, load the value 0, 0, 0, and output that. If you give it a non-zero value, let's say you give it 23 as the input, then you'll skip to line 5, load the value B, which is 999, and then you'll output that instead. Not super complicated, but hopefully you get the idea that now your little man can say, if this happens, do that. If this happens, do that. That's your simple BRZ and BRP. So in review, you should know what the BRA command does. So it's useful for creating loops in your code. If you want to have some practice with it, you can use this to fill up all of your memory addresses. And a challenge would be, how can you create a while loop using these tools here? So we're going to stop there, and I will see you at the next lecture. Just to remind you, don't memorize the machine codes, do know the little man computer process, do know that the little man computer can do both loops and conditionals and variables, and just understand that real world assembly code is very, very similar to the assembly that we've been talking about in here, just slightly different for each specific different computer architecture. Right, see you next time.